Good afternoon. I have about 5 minutes to talk to you about making for every student in K-12 schools. And notice I put every in bold because that's important. Every student deserves the opportunity to make. This is a typical picture of students in a classroom. They're more excited about what's going outside the classroom than what's inside. And I want to incorporate making inside the classroom. So here's a taco. When you have making activities, it looks somewhat similar to a taco. You have three things that you visibly see. So the shell, the vegetable, and the protein. In making activities, it's very similar. You have the teacher, the student, and the making activity. But what you don't see that goes into the making activity are the spices, the lime juice, and the heat that makes that taco delicious. So we have teacher educators, we have community support, you have parents. So you see that I'm a college professor. And this is my math for elementary ed class. And they are learning about the relationship, Euler's relationship of edges, vertices, and faces of polyhedra. Here they're learning to look at labeling the edges, vertices, and faces in a 3D form, but then a 2D model or 2D representation of what it actually looks like if you're doing paper and pencil as well. So they're forced to see the connection between 2D and 3D in this sense. And they're using this to learn mathematics. And they're going to be teachers in the future. Traditionally, when we talk about 1/2, students shade in 1/2, but the other half is still there. But with Tinkercad, I had second graders basically move the cutter over the half, and then when you group the pieces, the half disappears. So they actually visually see what it is to only have a half. Mathematical discussions can happen in this sense, because then you look at, they started looking at, well, is it really a half if we only cut it this way? There are other ways to cut a half. And then we print it, we either 3D print it or we laser cut it, and then they could visually verify it. And then next step, they could actually go and make those pieces themselves. So this is a connection inside the classroom. No, it's not a making activity per se, but the skills are built there so that they can do it outside of the classroom as well. This is your typical Pythagorean theorem problem. X and Y. Solve for X and Y. And it's really difficult to see where the right angles are for Pythagorean theorem, right? So being as I'm a teacher, this is the typical thing that I use to in my class to see where X and Y are. But then as you move the box in different angles, you can't really see where all the right triangles are. So with Tinkercad, you could go ahead and model it, and then they could print it, and then you hold it physically in your hand. And the mathematical discussion then becomes even more rich. Now all those three pictures are connected, and I know this is more of a trig example, but so this is a oblique cylinder. And the activity for this is you take a piece of paper and wrap it around the cylinder, and then you chop off the top and bottom. When you unwrap the piece of paper, usually I don't usually show the graph right off the bat. You ask students to think about what that would look like if you unwound it. Trust her. If you don't trust me, trust her. She's a teacher in one of my in one of my professional development sessions. And when you unwrap it, you could then discuss then what attributes to that oblique cylinder cause that. And then, of course, those are math examples. These are kind of general things that we do as well with local teachers, Maker Ed, and we connect the teachers with the future math teacher or future teachers in general in our university. We also reach out to the community, and we have the picture on the left is a general how to 3D model and print night, and on the right it's $300, make your own printer, take it home. So, I mean, we had community engagement from like bakers and cooks and things like that. So let's all make a delicious taco together.